Sneha, what is your note? Please read a bit clearly and loudly so that your friends can understand. And afterwards, present it immediately.
Namaskar and good morning to respected our science teacher and all of you, my dear friend. As you all know, it's me, Sneha Malathakuri from Group Einstein, and I'm here to read some notes. Electric Electromotive force, the amount of energy converted from non-electrical energy into electrical energy by the source of the electric current is called the electromotive force of the circuit. EMF, energy supplied by source electric charge. The energy gained per unit charge is also called electromotive force of the source. EMF SI unit is volt. If an electric source supplies uh, energy to produce 1C charge, the EMF of the source is called 1V. The amount of energy converted from electrical to non-electrical by the electric load when one unit change flows in it is called potential difference, PD, or voltage V of the circuit. PD stand for work done by load. The SI unit of voltage is also a volt. 1 VPD is that in which 1 joule work is done by the flow of 1 coulomb charge. 1V is equals to 1J upon 1C. EMF and PD both are measured by using voltmeter. And difference between electromotive force and potential difference. EMF, electromotive force, is the amount of non-electrical energy, and potential difference is the amount of electrical energy. Electromotive force occurs in the internal circuit, and potential difference occur in the external circuit. Electromotive force is measured in an open circuit, and potential difference is measured in an closed circuit. Next is electric resistance. The electrons which are free to move from atom to atom are called free electrons. the conduct the conductor possesses the flows of electric current through it. The property of the conductor is called its resistance. The resistance of the conductor is its property that resists the movement of free electrons through it. The SI unit of resistance is ohm, and it is denoted by R. And next is the relation between the current through a metallic conductor and a potential difference across its end was studied systematically by the German physicist George Simon Ohm in 1826 AD. This relation is known as Ohm law. Thank you.
Thank you very much, Sneha Malathakuri. So, children, you have to be prepared for explaining the notes that you have made. So, yesterday you have discussed up to here. Yes or no? Electricity. Good. One formula was there, and I said we'll be discussing next week. What is the formula? R equals to V by I. What is R? Resistance. What is R? Resistance. What is V? Voltage. What is I? Electric current. So resistance is expressed, or the SI unit of resistance is ohm. Ohm, but denoted by omega, like this sign. V, potential difference is expressed by voltage, in voltage unit, and electric current. These things we have to keep in mind. Okay, children. Now, in today's class, what kind of things they are going to present? Let's check. And will you be there to express present? We are going to present. Excuse me, we are going to present. Tesla? Tesla group not completed. Oh, Tesla groups, I think some person was, some percentage was completed and some not completed. Okay, I think if we do in this one, from where this will end? So I'll just over this also, then it will be easy for you. Okay. So from Jodo, actually, this Yeah, so here we can see. And then we are going to explain this question. Today, Ohm's law, George Simon Ohm, and what relation he is derived, V equals to IR, and what out of there? I think there are some circuits. So this is one electric circuit, a resistor. Yesterday we discussed voltmeter is connected in parallel connection and ammeter is connected in series connection. Parallel connection, what is this? Series connection. And then combination of resistors or loads in circuits. And some formulae are also there. Check it. And parallel connection. Then I think the heating effect of electricity. No, okay, okay, that is there. So what are they going to present? Let me welcome on the stage the presenter from Tesla, Nicholas Tesla. Who is going to present? Sorry? Oh, you will present and Sushil will explain. And my where? Like Canada?
English one. Con nhớ cho mình phải nhớ ra.
Where am I?
Không, không biết tôi hỏi tao nhắn nên
I keep my here. I also become confused. Okay, so okay, the presentators are Sushil and Anmol. So who is going to read and who is going to explain? Who will read?
You read.
Okay.
I don't know to explain. No, you can explain nicely. I will.
Just observe there and then say. Okay. Sorry. Is that okay? Or one more 40?
Huh? The guy I love you.
I already downloaded.
Yes, sir.
And you can go in that download one. Go download it. Yes, you can download it.
Oh no.
Everybody please pay attention. Eh? Otherwise you will be in tension. What do you think? Open only at the top.
From beginning. Right.
Okay.
No, sir. We have already completed profile. This also completed. This also. Yes, sir. Yes. Namaskar and very warm good morning to honorable outside teacher and my dear friends. As you all know, it is Sushil is standing here to present some portion of chapter electricity.
Slowly, if you prefer.
The relation between the current through a metallic conductor or potential difference across it was studied systematically by a German physicist Georg Simon Ohm in 1826 AD. This relation is now known as Ohm's law. It states that the electric current passing through a conductor is directly proportional to the potential difference across its two ends at a constant physical condition, temperature, cross-sectional area, length, nature of material, etc. You can do that once.
You can make a very small. Cross that, that area. And then the right side.
Yes.
Yes.
It states if T is the electric current through a wire and V is the PD across.
That is I.
If I is the electric current through a wire and V is the PD across its end, IV or V into 1, V is equals to Ri. Here R is electrical resistance of the conductor where is used as constant. R is equals to V upon I. Equation first. We get that here R is equals to resistance, V is equals to potential difference and I is equals to electric current. According to the above relationship, resistance of a conductor is the ratio of the PD across its two ends to the electric current flowing through it. This down is also. It is already combination of resistor load in circuit. Here is given diagram. The relation between the current through the metallic conductor and potential difference across its in was studied systematically by a German physics George Simon Ohm in 1826, and this relation is now known as Ohm's law. And it states that the electric current passing through the conductor is directly proportional to the potential difference across its two ends at a constant and physical constant. It means that it denotes that the electric current passing through the conductor which pass electricity is directly proportional to the potential difference across its two ends of a constant or physical condition, temperature, cross sectional area, length, nature of material, etc. It's are the physical or constant conditions. If I is the electric current through the wire and B is the PD cross its end, IV or V into 1, V is equal to Ri. Equation 1, here R is the electrical resistance of the conductor which is used as constant. R is equal to V by I. Equation 1. We get that here R is equal to resistance, V is equal to potential difference, and I is equal to electric current. According to the above relationship, resistance of a conductor is the ratio of PD across its two ends to the electric current flowing through it. And here is given combination of resistors load in circuit, and this is parallel combination of load, and this is series combination of load. Resistor or electric loads are connected in two different major ways as follows, and they are series combination of resistor and parallel combination of resistor. By saying this much, we like to conclude our presentation. Thank you.
Thank you very much, members of Tesla. Actually, children are very much attentive and active, so they prepare their slide very nicely, and now they need to practice a bit more for presentation also. Is that clear or not? Remember, presentation provides you 16 marks for practical. Understood or not? Your participation 4 marks, presentation 16 marks, and your terminal examinations, how much marks? 5 marks. So 16 plus 4, 20, 20 plus 5, 25. Just get the blessing from whom? Nicholas Tesla. So Tesla is here. Nowadays, this is the age where Tesla has become too much famous, right? Tesla electric cars. Whoa. Elon Musk. Oh. Rockoda. Oh. Yes or no? That's why great students, they don't do different things. They do the things differently. Matter is like that. So, Tesla, if you write your name, then it comes. Children, one thing you have to remember. George Simon Ohm, he was the scientist from Germany. George Simon Ohm. He studied the relationship between two things. What are the two things? One is current and another is voltage. If there is a conductor, current flows from one place to another. So in that conductor there is current as well as what is there? Voltage. So he studied the relation, and what did he find? He found one relation. What is that? Directly proportional to each other. More current, more voltage. Less current, less voltage. For example, if there are three batteries, let's say, and here are 10 batteries. Batteries are sources of electricity. Are a source of electricity or not? So, from 3 battery we can get more current, or from 10 battery we can get more current. From 10 battery. From 3 battery, or in 3 battery there is more voltage, or in 10 battery there is more voltage. Okay. Means More current, more voltage. Less current, less voltage. That's why this is directly proportional. George Simon Ohm, he found that relation and he said, now we call it Ohm's law. If you find new thing, then it will be your new law, right? If Anmol finds new thing, then what do you call it? Anmol's law. If Deepak finds new thing, Deepak's law. If Arush finds new thing and proves himself, what do you call? Arush's law. Gemini law. One person is there, Gemini, let's say. One person is there, Nistara's law. Arina's law, Krizel's law, Desara's law, Ishwar's law. I haven't given anything but law. I must give something new, right? So, relation is like that. And what does Ohm's law state? What does it state? The electric current passing through a conductor is directly proportional to the potential difference across its two ends at a constant physical condition. Suppose current is flowing through this one. This is a conductor. What is this? Conductor. If the current is flowing and there is voltage, then what did he say? Current and voltage are directly proportional to each other when conditions like temperature is constant, area, cross-sectional area is constant, length is constant, nature of material is constant. They must be constant. If they change, then they are not directly proportional to each other. Yesterday we discussed good conductor, semiconductor and insulator. You tell me, can current pass from insulator? No. So it has very high resistance, isn't it? But if the current is allowed to pass through semiconductor, its speed will be a little bit more, isn't it? In conductor, very high. So these conditions must be constant. Then you have to remember. What to remember? One formula must be derived from this one. What is that formula? I will just tell you. Formula is here. George Simon Ohm's formula. Here it is given. If I is the electric current through a wire and V is the PD across its ends, according to Ohm's law, what is given here? I is directly proportional to voltage or V is directly proportional to I. We can change. Then this proportional to sign, remember, what is sign called? Proportional. It must be changed by using a constant n equals to. So they have used here one constant. What is that constant? R. What is R? Resistance of the conductor. So there is one triangular formula. Triangular formula I told you how to make. What is the formula? B equals to I R. Next formula is here. Understood or not? So from here we can get three equations. One is B equals to I equals to B by R, and R equals to B by I. This is one technique to remember, but the formula, right? So the formula that is obtained from Ohm's law is B equals to IR. Okay? And yesterday some numerical problems were discussed. Please look at your numerical problem. What is the question here? When an electric iron is connected to 220 volt circuit, 5 ampere electric current flows in it. Calculate the electric resistance. So, what is the voltage? Hello, voltage? 220 volt. Current and electric resistance we need to calculate. What is the formula of R? B by I, and it comes 44 omega, right? This formula must be remembered. What is the formula? B equals to IR, or R equals to B by I, or I equals to B by R. Formula must be stated in mind. Okay, let's go to their presentation. What was their presentation? Their presentation was here. It was found here. And finally, actually you can see here bulbs. How many bulbs are here? How many bulbs are here? 3. We are not talking about this source of electricity. We are talking about bulb. How are these 3 bulbs connected? Series. They are connected in the same side, no? And here, how are they connected? Parallel. How to know whether that is series or parallel? If they can be operated with only one switch, that is series connection. If they can be operated with different switch, what is that? Parallel connection. In our class, there is bulb, there is fan, and outside also there is bulb, right? So, how many switches are there? There is one switch or many switches? Many switches means what type of connection is that? Parallel. Only one switch, all they work means series connection. During TR, that jhilimili batti is available, right? So many are there. Just connect one, jippegi. You take out, goes. So that is series connection. These all are parallel connection. About series connection, parallel connection, their formula. So students will explain in next period. When will they explain? Next period. Is it okay? All right. Now, students. So what are we going to do? I'm going to tell you next thing. That is, what is that? First of all, this numerical problem you have to do in your copy. Please mark it. These 2 numerical problems. If you have already done, it's okay. Now, I'm not going to tell you to do once again. Now, next one is, today we'll begin MCQ. Because if the work is given a little bit more, then you can do it a bit fast. MCQ. Please, let's check what is given here. What is the question? You take out your book. Oh, Baba, why it's swelling? Take the correct alternative. Okay. Einstein group. Einstein. Tell me the correct answer. Einstein. What is the rate of flow of charge? Einstein said electric current. Is that true? Yes, that's right. That's right. Also, now group. Now it's the turn of Newton. Newton. What is the melting point of nichrome? 1400 degrees centigrade. They found it. That's right. This is 1400 degrees centigrade. Right? Now Tesla. Which of the following factors does not affect resistance?
No, pressure.
What do you think? So resistance depends upon thickness, cross-sectional area, type of material, temperature also. But what is the correct answer? Pressure. That's right. Okay. Now it's the turn of Mendeleev. Is there Mendeleev? Then Whittaker is there. Then Edison. Okay, Edison turn. Which element is used to make the filament of an electric bulb? Tungsten. Tungsten is there. Okay, you just mark this also. Next, which one is left? Hawkins. Stephen Hawkins. Number E. Which formula can be used to calculate electric resistance? BYI. This is correct. Okay. So this much is your classwork. First of all, note making, and then this MCQ up to number E. Is it okay? So please continue your work, and I will check your activity as